Welcome back to my YouTube channel. I am Tanishka and today we are going to be talking about something very interesting. Do you want to know what it is? Today we are going to learn about isotopes and how they're different from atoms. We are also going to learn about the relative atomic mass and how it is calculated. So without further ado, let's get started. So you might be wondering, what are isotopes? Because chances are you might have never heard that term being used in your daily life. Well, isotopes are atoms that have a different number of neutrons but the same number of protons, causing them to have a different mass number. Some elements have multiple isotopes that occur naturally, and isotopes are generally named as the name of the atom followed by the mass number of the isotope. Let's take a look at a quick example over here. This image shows us the atomic structure of the three isotopes of hydrogen, which are protium, deuterium, and tritium. What are the similarities and differences you notice between them? One of the main difference or the key difference between them is that the number of neutrons keep increasing. As you can see in protium, there are no neutrons. In deuterium, there is one neutron, and in tritium, there are two neutrons. There is also a very significant change in the mass number of hydrogen because of the addition of these neutrons. In protium, the mass number of hydrogen is 1. In deuterium, the mass number of hydrogen is 2. And in tritium, the mass number of hydrogen is 3. Now, let's move on to relative atomic mass. In case you're wondering what relative atomic mass is, relative atomic mass, or simply known as atomic weight, is the average of the masses of all the isotopes of a given element when compared to the average mass of another element. It can either be hydrogen or carbon. The abundance of an element and its isotopes play an important role in calculating relative atomic mass. Here we have a short example. Let's take the element chlorine, which has the atomic symbol Cl. Chlorine has two isotopes, chlorine 35 and chlorine 37. 75% of all the naturally available chlorine is chlorine 35, which means that it has 35 neutrons in its nucleus. And 25% of all the chlorine available is chlorine 37, which means it has 37 neutrons available in its nucleus. Now, you need to find the relative atomic mass of the element chlorine. So what we are going to do is that we are going to multiply the amount of neutrons in the nucleus, which in the first isotope, chlorine 35, it is 35, and multiply it by the abundance percentage, which is 75%. And then add that with the second isotope. The second isotope is chlorine 37, and it has 37 neutrons in its nucleus, and it is 25% in abundance naturally. And then you need to divide that quantity by 100. As you can see on the bottom right corner, you get the answer as 35.5, and 35.5 is the relative atomic mass of chlorine. That being said, thank you very much for watching, and I hope you learned something today. I am really glad if I did save your exams, and be sure to subscribe to the channel. Also, if you have any questions, please check the description box down below for my email, and you can ask me personally or you can ask me in the YouTube comment section. That being said, thanks for watching once again, and goodbye. See you in the next one.